Welcome everyone to another fun little tech update live stream here with our Linux and open source goodness, and also not something vintage as in Oko whatever previous video, but this time what you can actually use at home for your latest and greatest. So not a paid advertisement, just the stuff we are running here. So today's video x32, an alternative ABI application binary interface for your latest and greatest AMD 64 or Intel Linux 64-bit, 64-bit Linux business. And while this ABI existed already for quite some while, so what does it mean? Generally, when AMD, by the way, not Intel, invented the 64-bit innovation and revision and update of x86 processors, obviously you were running all the stuff 64-bit back in the day, whenever that was, probably 18 years ago. And 64-bit, as you probably can imagine, going from 32-bit to 64-bit, everything was 64-bit because 64-bit, larger databases, more address, more memory and everything. And as we already know from the SGI MIPS, Octane, the issue, or even the Sun UltraSpark, the issue with that is 64-bit means not always faster, because often your data is actually not 64-bit, just some RGB pixels and even a small database or even your mail client. And so 64-bit per se does actually not mean faster, it just means more address space. And in many instances actually is a little bit slower. And the SGI people from back in the day on the Octane and stuff, they actually solved this by simply not doing everything 64-bit, but allowing 64-bit, but having the address space, the pointers 32-bit. This can improve performance because this pointers, in probably also next videos, some programming 101, pointers meaning in most programming languages, pointing to somewhere in memory. So this pointer in your C, C++ and so on. The quantity of addressing memory. And when you have 64-bit pointers, they are basically twice the size. So all the pointers, which you might have many, like every email, every compiler, in like your GCC, your compiler, every reference to something in your compiler might be 10, if not hundreds, thousands of pointers there, or email and icons, and your inbox might be 10,000 of pointers of, actually multiple pointers of subject and stuff. So the stuff adds up quickly. And so similar to SGI MIPS, where they invented that already over 25 years ago, namely N32, their application binary interface of having just 32-bit pointers for the sake of saving program memory and actually much more important cache. And this is also what the Linux x86 people have done, the Intel, probably some Intel people, and they call this x32. And this is different from just running 32-bit, because the problem with x86, also next video, maybe tomorrow or something, all the instruction set architecture, the insane complexity, because as they list here, x86 historically has very few registers, basically only 6 general purpose integer registers. And so just running good old-fashioned x86 386 code from decade actually doesn't cut it, because it is actually pretty slow. So this variant here, x32, something very few people use, has huge benefits over legacy code, because not only can it use all the 16 or 15 somewhat integer registers, so many more registers over legacy code, that improves performance drastically over just running legacy 32-bit code. So this stuff exists for quite a decade. Very few people use it, very few distributions support it. But hey, we are here to the famous unsuccessful Woman distribution guide. So hey, of course we support this, right? In our precious fine little T2 build from source distribution. I packaged this up with all the configuration data over a year ago. I never really tested it too much. It's like a year or two ago, so it's like, yeah, let's test this a little bit. It somewhat worked, all the quirky configuration stuff. It's only that the last nights I actually went here all the extra effort of compiling here full distribution, because it is a beauty of our T2 source distribution, like, hey, just compile the stuff. So I last night fresh here out of the bit baking AMD silicon, fresh ISO, and I've done some benchmarks, because when we take a look here in the original presentation from those Intel folks here, of course they list here all the details that I went through here, all the drawbacks and so on, and they also have some performance numbers, like this stuff can be like 5 to 8% faster, and they also have here some graphs. So let's take a look at that. So that is here the build from today, and unfortunately it's not always faster. So there you see your mileage may vary even if you a decade later, and you think this should be pretty tested by now, and it's not always faster. So we have here x32 optimized for O2 and optimized for speed. By the way, optimized for Zenver 2, running here this precious AMD Ryzen 3950X. So as usual, you test something and some anomalies. One strange anomaly is here that the regular, what everyone running along at home is running, somehow is vastly faster. I rerun this a couple of times. So this is building bzip2 size optimized somehow like twice as fast. First I thought it's some random number garbage stuff, but I repeated this a couple of times. Always came back with the same numbers, so no idea why x64 is maybe some optimization anomaly that just this case somehow happens to fit into the cache precisely, or some crazy stuff. Somehow it doesn't happen for the 32-bit variant. So again, this is this new alternative 32-bit pointer x32 variant. And what we see here, we should compare here the x3202 and x6402 here, and what we usually see. So this is a build time, and so the beauty with T2 is that I have here two pretty matching builds. So we can also take a look at the compile time already, because we also have the runtime meaning the runtime of the benchmarks. But because we have here pretty identical builds, we can exceptionally also take a look at the build time, meaning how does the GCC compiler fare in real life. And indeed, it often is a tiny little bit faster, which is of course what we should expect with, again, the 10,000 or 100,000 of pointers within the compiler, referencing all the source code, all the instructions, all the all the SSA trees. It's building up in memory. So this is of course so far so good. 11, so this is in seconds, so 11 point, it's a freaking Ryzen, right? So if we would build this on an SG Octane, this would build for 20 minutes or something, but hey, it's a freaking Ryzen 3950X. So just 11.8 to 12.47, so all the stuff usually is a tiny little bit faster. Well, usually, except sometimes when, yeah, the build time is a fraction of a second, so yeah, micro benchmarking your cache warm up, but usually faster, except for this really strange case, whatever fits directly L1 cache or whatever the case might be. Also for size optimization, except this one outliner, usually if it's not the same, somewhat fraction of a second, but it can be a tiny little bit 5 to 8% faster. So far so good. Runtime also, as we see here, O2 28 point something. So hey, you get a little. Usually you buy a new CPU for that, get a little bit free performance upgrade, except when you don't. Here's also one anomaly as well. Here's this GNU PG. I thought it could trigger some assembly, so there are basically two caveats with that. The one caveat is if there is assembly optimization, I thought I built GNU-PG for this benchmark without, so no idea why this GNU-PG is that much slower for some strange reason. But there you see benchmark test and more tests, because if you're not benchmarking testing, then yeah, random stuff, just like this. So it's a tiny little bit faster, except when it's like twice as slow. It could easily be assembly optimization. I thought it's disabled. I took a quick look. It didn't on the first glance look that it's building that, but yeah, this is also the caveat. It's if your stuff has assembly optimization and it's not ported to x32, the stuff will break, like either not compile or segmentation fault for having the wrong pointer size in your fine handcrafted assembly. And also the thing is that if you build, I'm somewhat tempted, but yeah, not. If we would have 100,000 subscribers, I would now try to build a whole system. The problem with that is Firefox, like if I want to browse the internet with running this on my main system, yeah, Rust and just-in-time compiler. So yeah, the second caveat, probably I should finish the sentence. The caveat is like, yeah, probably not supported. So yeah, Rust, maybe they have x32 support, maybe they don't, but probably even if there's Rust for x32, probably there is no Firefox JavaScript just-in-time compiler. Maybe there is, correct me if I'm wrong, but yeah. The second caveat is that because you limit this artificially to 32-bit pointers, you certainly only have 32-bit address space, meaning per application 4 GB or 3 point something, depending on the Linux address space layout. So might still usually not be an issue for most people. However, even like running some yesteryear's Apple hardware that only shipped with 4 GB, but the 4 GB also mapping shared libraries, memory mapping, some file I/O. So on modern applications like a modern web browser, you might eventually run out of this 4 GB address space per application. So even if Firefox would work and you have 100 tabs open, might not fit in 4 GB. So yeah, two caveats: assembly and just-in-time stuff in Rust maybe not supported, and yeah, 4 GB maybe not enough for everyone anymore. However, it might be a solution if you have a high-performance use case, microservices, serverless stuff where you serverless run 32 whatever microservices on your servers. Maybe this is for you, and certainly embedded applications, some car media stuff, or God forbid if you run some x86 stuff in your rocket mission control stuff, then yeah, maybe this is for you. So embedded microservices or other services might give you some performance back. And certainly here the size, when we take a look on this benchmark stuff, the size is a binary size, so this is indeed usually a tiny little bit smaller. Why is it not more smaller? Why? First of all, the majority of the instructions are taken up by instructions like add, subtract, multiply, divide stuff. So it's not like halving this, and the binary size includes all the strings like hello world, help usage, and all the other stuff in a compiler and compression program. So all the size reduction is only purely in pointer stuff. So yeah, it's a tiny little bit smaller, but not that much, obviously. The good thing is with this T2 stuff, unlike other people, it's like, hey, here's the stuff, here's a presentation, or freaking PowerPoint, because we are running Linux desktop and we certainly do PowerPoint presentations. Unlike others, I can give you the ISO image. So I will publish here after the video the mostly working ISO image. Let's, where did I even had this? I can show you, last but not least, too many terminals. We also have some comments. I get to the comments in a second. Did I run this maybe here? Maybe I did. VM-efi, let's reinitialize this, create a new image. Let's boot this ISO here. This is certainly why you share, like, and subscribe for this channel. All this in-depth stuff. So this is the whole ISO that I also benchmarked. Oops, also not full screen. Darn. What is full screen? Maybe. Famous lost words. It's mine is small technical difficulties because I run over to display. That is why we don't want. Why is this also not zoom to fit? Darn it. Zoom to fit. Here we go. So to show you how fast this is also, this is that you also hear something else that might be of interest. We are running in T2 not only set standard compressed init RD, but also set standard compressed packages. So this installer, since already 3 years, blazing fast with set standard. Also yesterday, a new set standard version that is again a little bit faster, another 5% faster compression. So watch how fast we are installing this. Edit partition table in just 1 second. GPT new 1 GB because whatever, type EFI whatever, all the rest for Linux. EFI something writes this, yes please, and we continue. Probably I should actually make a auto format this to make this faster. Mount a creative file system. Let's XFS used this a second ago. Here's this EFI creative fat for boot EFI, and then watch this installation because 5 to 8% faster set standard, latest version from last night, plus x32, another 5 to 8% faster on a freaking epic thread ripping AMD Ryzen 3950X. Start package manager and so install everything. So this is how fast we're installing a minimal image. There's only one small little caveat in that I tested this already before the live stream. Always test, more test. I have no idea why this doesn't extract. Actually, maybe this is actually simply a premature, and maybe I should actually rebuild this. Maybe this is only somehow a control seed cancelled archive. Maybe it's not like a bug or something. Maybe this is just manually typing too fast, something truncated tar. I will check after this video. So skip this for this is enough. So I will double check this, but otherwise, this is the whole installation. So much to AMD Ryzen 3000 and 5 to 8 performance there, another 5 to 8% performance there, and at the end it installs in no time. Live here on this channel. Europe freaking still Berlin. Maybe I should actually make this the default. Configure grub2. This grub2, previously we had a tiny little bug that this didn't auto install. I fixed this also some week ago. So thanks for sharing, liking and subscribing, making this distribution great again, one live stream at a time. This is full installation, unmount file systems and reboot. So 5 to 8% faster here and there. I will double check this LLVM or CLang clang issue that we had there and publish this ISO for you playing along at home. Some caveats apply, as I mentioned. Some assembly might not work, and some certainly Rust and Firefox and stuff, but feel free to play along at home, send me patches, comments, leave me in the comments below. What do you think about this? Is it worth it for microservices or embedded systems or for your performance optimization? Or is it some solution looking for a problem or time not well spent? I tested this, so X comes up at least in QEMU with whatever, so much to this ISO at least. Probably I should test this on real hardware if AMD GPU works or something, but otherwise X works, at least in virtualization. Anyway, I hope you found this interesting, small little details where you can optimize the heck out of stuff and what funny exotic stuff exists there in the wild. And another fun little anecdote, or actually 2 more data points, that This, as I said, this is not new. SGI has done this and also exists in Linux N32 for exactly the same thing because SGI stuff, MIP64 was already 64-bit in the 90s. And certainly nobody had 4 GB. You had your Octane with 256, 512, or if you were super rich, maybe 768. But we also have done the same, not only we, but also Red Hat and stuff, but also we at Rock Linux NT2. We have done the same for Spark 64. Basically, back in the day, not sure if they still do this, but back in the day, Spark 64 ports usually defaulted to 32-bit by default in Debian land and stuff for the performance, just exactly with Ultra Spark stuff. Basically, nobody had more than half a gigabyte of memory. And last but not least, of all things, actually I should have created here, P3, you have seen this in the previous videos. As far as I remember and have seen, the Sony Game OS in PS3 land is exactly running like this in PowerPC. So what doesn't exist in IBM AIX or Linux PowerPC exists for, as far as I heard, the P3. So because the P3 only had 256 megabyte of memory plus 256 for the RSX, you certainly don't have more than 512 megabyte of memory plus a little bit of virtual address space, but yeah, YOLO, whatever. So correct me if I'm wrong, but I think Game OS is running exactly with this kind of setup that probably no one else is doing on PowerPC. 64-bit PowerPC with 32-bit pointers, because yeah, Sony certainly also had to optimize the heck out of their PS3 setup. And yeah, this stream was brought to you exceptionally with 0 job frames, amazing stuff. Let's see what comments we have. And thanks, Glaucus, for asking how we're doing. We're doing fine. Parts to build EVAP cooler for the home. Does every program, so Matthew Smith asks, does every program on the system has to be x32 or could be most software? Yeah, you could mix it. It doesn't need to be, so the Linux kernel, the only thing is your Linux kernel, you need to compile with x32 enabled. Some distributions might not ship it with it enabled. You can freely mix it, so you can have one program 386, like good old-fashioned 80s stuff, some programs x32 and some programs 64-bit x64 or x86-64, whatever you want to call that. You can freely mix it. However, you need the libraries multiple times. That is called multilib, that you probably have seen on your system. And in T2, actually, by default, the way I have set this up a couple of time ago is that you still get the 64-bit variant. By default, of course, T2 being flexible, compile from source scripting stuff, you can change it. Build x32. So by default, again, your mileage may vary, you can change it. But by default, when you enable this option, actually, did I spoke? Maybe I spoke, wait a second. So much too, already so many combinations, don't even remember what I've done here myself. Okay, so I remembered wrong. So you get 32-bit old-fashioned legacy stuff if you would run some binary-only stuff from the 80s or 90s. And the multilib directory for this is, by the way, libx32. Nobody is stopping you from having all of three, so lib64, libx32, and so yeah. However, if you need shared libraries like libjpeg, libx11 or whatever, Mesa, LLVM, you would need to have the shared library variants for all of those ABI variants, which quickly gets out of hand, which I personally, in T2, by default, we don't have the multilib variants. For everything, we only have the C library, so we don't have libjpeg, libx11, and so on multiple times. But yeah, you could build this if you wanted to, but yeah. So you could run everything libx32 except big UI applications, but yeah, it would result in quite some shared object cluttering there and stuff. Micro Colonel says, honestly, better off with explicit pointer compression. If you have a large collection of pointers working, so probably in a collection, it's cheaper to transform them. Interesting thought. The Fury asks, did they remove x32 from the kernel? No, not yet. They once asked, but it's not yet removed. And I wanted to give you an overview. I'm actually thinking about maybe I do this for a test and have this running of some production servers just for the test of it. It's in general not too bad to test random stuff, and it's also another barrier of people breaking it or other similar stuff. But even better decompression when it's already faster. L4 decompressions, very exciting stuff. Using T2 for main desktop. Mike Han asks, would you recommend using T2 as your main desktop as well? That's certainly what I'm doing. Although it is certainly, well, even so, again, I said this before, I neglected the desktop stuff the last decade because they're busy with live and commercial application stuff. So only with you guys watching, sharing, liking, subscribing here with this YouTube stuff, I'm actually updating all the stuff and making it super great again, which we are slowly getting into. So some Rust and Cargo stuff, not for the faint-hearted, but the issue is, of course, similar to Gentoo. So if it doesn't stop you, like Gentoo kind of emerging from the sources, then yeah, sure. I certainly like it very much. I run nothing else, so certainly what you're seeing here, right? The next things I have to do is certainly Rust Cargo integration, multiple videos, not the most outstanding stuff because super complex and not the most bootstrapping friendly. I also have to update the OpenOffice package. I've update and clean. This is also why we got here this freaking AMD 3950X and 64 GB of memory to make all the super sized large packages super great again as well. So yeah, sometime soon further OpenOffice integration update work, and I probably also have to package Chrome, the web browser. Right now we have only Firefox, well, except Dillo and web browse whatever, or NetSurf. Because yeah, not the most satisfied with Firefox for two reasons. One reason being Rust and Cargo are not the most bootstrap friendly, and certainly still not VA API hardware isolated video. And this probably I should actually swallow the blue pill there or something and finally package this Google Chrome stuff. The only things I would have long done it a year ago, but my grief with large software projects, unfortunately, similar to Cargo and stuff, you need strange stuff to build Chrome, like what was it, like Depot tools or something of Google's own software distribution, random garbage. So yeah, but eventually, probably someday I need to anyway. But certainly totally welcome to try to use it for your desktop, and we need to update and make all the stuff great again for all the P3 and SGI fame anyway. So yeah, anyway, yeah, fun stuff. OpenOffice, back in the day I've built OpenOffice on PowerPC. Even probably back in the day, like 2004, I even built OpenOffice for PowerPC on a like G3 800 megahertz iBook. Not kidding you, that was certainly back in the day my fastest PowerPC machine. It only compiled a whopping 12 hours or 16 hours, but it was doable. Nowadays, stuff got larger and larger and larger. Nowadays, all the stuff. This is also the sad thing that you had the setup 15 years ago, but they constantly change the sources, certainly, but also the build system. So upstream constantly breaking stuff. And yeah, this is also why I turned to YouTube, because otherwise it makes no sense for my not one-man distribution to package all of the stuff without like any PR and 3 bucks a day income here. Super time consuming stuff, and just to keep the stuff building because they constantly update something. Let's see, what else do we have? T2 main, so we had this. But set standard didn't include, man, they say make set standard compression even faster. Yeah, pretty amazing stuff, super satisfied. Another day, so you see so many ideas, so much stuff to do. If I would have certainly working on the 100,000 subscribers, because if I could somehow finance work with like this YouTube stuff, I would like to add set standard firmware loading to the Linux kernel, but yeah, just for myself, a little bit pointless undertaking. But the more subscriber we get, the more fun stuff we do, and testing this fun stuff certainly here only for the 5,000 subscribers of you. Yeah, people depot tools, yeah, required to build Chromium, amazing stuff. Total mess and needs own bin directory. Yeah, this is also why I'm increasingly frustrated. You might hear this from some of the videos, certainly the IT breaking news stuff on the More Life channel. So much stuff broken. I really wonder how the big companies like Google, Apple, IBM and stuff build their sources, and Microsoft Windows and stuff. It's hilarious. All this large dumpster collections of sources like Chromium certainly get out of hands there. DTAT says spawn a container to build those large packages. Yeah. The Führer asks, OpenOffice, do you mean LibreOffice or actually Apache OpenOffice? So back in the day, there you see also how time flies and how stuff changes. We had, so back in the day, LibreOffice didn't even exist. So back in the day, we had OpenOffice when OpenOffice was still the one OpenOffice. And we only had like some alternative. What was it? Go OpenOffice or some other alternative. Nowadays probably OpenOffice is somewhat dead, maybe. So yeah, but I think a year ago I updated the Go OpenOffice or whatever that strange flavor was, because forks and more forks. This is probably Office, and not sure if I did I renamed this already. Probably I renamed the T2 package that previously was this Go OpenOffice thing to preserve some subversion history to LibreOffice. Probably also not blame, but you know, we get some drop frames. Yes, we unlock. But I think, yeah, Go OpenOffice, whatever this was some, I actually don't really quite remember what kind of thing that was. It's probably some alternative. It's probably like OpenOffice was probably a pain to build. Sorry. And some people like whatever that was, Go, Mono, whatever, GNOME, whatever. So much stuff, don't even quite remember. Anyway, so yeah, this is why I in T2 renamed the history. There's a package of Go OpenOffice org to LibreOffice, and we still have OpenOffice, but yeah, so much details. The last time also, so what you see here, this OpenOffice build is built from source like a year ago, but it didn't install like how it should. It's somehow installed in user garbage OpenOffice, like whatever. But then it's like, yeah, I'm out of time here and whatever. YOLO. So this package, the last time I built this LibreOffice package, is not yet installing amazing. It's always the 90-10% stuff. Like basically I didn't have time for the last 10% of making it install nicely, because hey, back in the day last year I didn't have the 1350X, but probably sometime soon, as certainly macOS had peak bugs, and who would want to run Microsoft Windows? So hey, back to desktop Linux, rocking my own stuff here, so making this stuff great again. Anyway, that's it for this video. As usual, I was reading the comments, but hey, we're only 36 minutes. Speaking fast here through the stuff. I hope you learned something and found this interesting. Google builds Chrome OS with Gentoo build system. Actually, really seriously, what the heck? Whatever. But there was even WordPerfect for Linux. Yeah, there was, but this was probably closed source, wasn't it? And IBM Lotus Symphony Open Office Fork. Yeah, remember this dark times. Apache Open Office. Yeah. Anyway, so that's it for today. I hope you learned something. I do some last minute testing. Actually, you know what? I need to do it anyway. Let's. Although the only thing is, let's create this image again, and let's QEMU that again, and let's install that again, and quickly check partition table, whatever. So this time let's just create everything Linux, because I'm not booting this anyway. But I think I probably, I didn't, whatever. So much to not typing that correctly, but YOLO. I only want to install this here quickly to see which package failed and rebuild this. I'm not really sure how this happened. But otherwise, if I go now for lunch home, then I probably, so that is LLVM. Let's rebuild that job here. Live on this channel, can't take too long. Slightly wonder how this happened. It could be some other live stream. I improved the T2 build time by simply backgrounding the compression task, like with a simple ampersand there in the bash cell. And maybe this is actually not reliable. Maybe the job maybe is killed or stopped when, like, we run this LLVM build, then we background this compression, and the next package build fails of some random error whatsoever. And maybe that is the issue why now sometimes I end up with this truncated and corrupt archive. Not really sure. Let's see how this goes. What else do we have here? I could actually, let's background this. Actually, the famous last words. I should have, you know what, let's not risk this also. By the way, let's, for the maximum performance test, vi config x32 config with tempfs. Let's re-enable tempfs, and then let's verbose build this. That always looks better here on the YouTube stuff. So what else do we have here? Minimal rootfs archive. Dita asks, download minimal T2 rootfs archive. Not really. It doesn't make much sense for me to publish even more stuff, as much random stuff I already publish. I would suggest that you take the minimal build there, the ISO, and simply compress all the tarballs. That is the beauty of the simple tarball packaging format. You can simply, in a bash loop, for fin mounted ISO like /media packages 20 point whatever 3 version packages for all those tarballs in a loop, tar xf this $f, and have it yourself. It probably makes the most sense not to publish more random stuff that people don't know what it is for and how to use it, and simply uncompress these packages yourself. What do we have? A question. You can wait for the completion of jobs in your script with wait. Yeah, I know this, but then the problem is we continue the build. So probably maybe because we might have 1 or 2 builds running or not. But yeah, probably maybe there are some job control stuff to either wait for any children or, yeah, actually not really sure. I need to watch this. This is only speculation, a random guesswork here. It may or may not be accurate. I need to gather more data points why this now sometimes happened. Let's start here our nice activity view, because you can never have too many activity graphs in your YouTube live stream, obviously, with all the... Anyway, but yeah. Looks like your audio a little bit out of sync. It should not be, is it? Well, I capture this intentionally through the camera, so it theoretically should not be out of sync. Maybe it's YouTube messing this up. Let's check with, although I can't even be sure with this Pulse Audio garbage. But yeah. But yeah, that's what you get from the default OBS configuration and Pulse Audio stuff. And yeah, super huge Pulse Audio fan here. Not. But what? Audio is gone? Shouldn't be gone. It looks view metering here for me though. Let's see. Whatever. Something. Oops, that is also the moving here the wrong stuff. So yeah, only a couple of minutes later, let's grab a little more coffee. Let's see what's going on here. Okay, so the message wasn't my wife. So no wife and baby waiting for me. That is already good. And are in sync. So yeah, thanks for checking. Probably are you running also Pulse Audio? Might be your local Pulse Audio client there. Yeah, CPU, not a paid advertisement, previous build here. Pretty satisfied also. Here, tempered glass stuff, right? Previous build. Pretty amazing. I'm still wondering if I should waste some extra money because I'm still running the mini ITX board. Still wondering if I should waste some extra money for not too much of an improvement for a new X470 full-size board, because theoretically the mini ITX board, I still have the last year's 2700 AMD Ryzen there for the mini ITX build. So yeah, and the memory. So previous video, largest consumer memory module updates here, as well as the CPU. So yeah, I actually have spare memory and a spare CPU. So anyway, but don't forget to like and subscribe for the also wrong mouse pointer. The more subscribers, the more fancy hardware we can afford. And if you want to see real thread-ripping or epic stuff here, this is, by the way, the apparently it is waiting. As you see, this is the background job I spoke about. Unfortunately, not yet very parallel running set standard compression. This is why I background job that. So at least for this case of one job, like manually T2 build target one job at a time, it's actually waiting here nicely. So yeah, not yet sure what this hiccup is. Actually, I should have probably double checked that. Do I still have this running? Let's know that. Let's set standard decompress of MNT source packages. That was LLVM write to dev null premature, and yeah, sure enough, that is, how large is that even? Let's see, that is, it is also H for human readable, right? 2.9 megabyte, yeah, that is freaking small. Let's see what we got now with x32 toolchain packages. Was it LLVM or it was LLVM? Let's see what we get now. 4-H. Now we got 30 megabytes. It for sure looks better. Let's regenerate the ISO and reboot. But then there are only a couple of packages missing theoretically. Does it? Can check this in a second. But the installation is... oh, thanks for the Superjet donation there. Highly appreciated for keeping all our open source vibes here in positive and stuff. So this is a ISO created, and what did I wanted to check? All right, I wanted to run the create error list for config x32, and so maybe I touched them. So much to hiding your errors with touch var adm log 0. So you don't need this and size. So yeah, okay. So basically Meson and Ninja and Perl, yeah, so basically nothing really vital missing. Maybe eth-tool that requires some new library because some mh whatever or something. Need to check that, but yeah. Anyway, nothing really vital missing. This is just cross-compile. We have this Meson and Ninja for all cross-compiled also because this is a cross-compile just because test setup. Also we are building x86 on x86, but anyway. So yeah, that is the ISO regenerated. Where's our here, new ISO, new boot. And another day I probably also patch this to default to zoom to best fit and so on. So yeah, this was just some random build fluke. Ah, darn, also menu handling. This was not x32 related. GPT, new 1 gig is enough for type EFI whatever. New all the rest, that is fine. Write that, yes please, and then quit. And then create a file system on this partition. Let's use old-fashioned riser because random testing, why not? The more the test, the better. And then create fat on boot EFI. And yeah, another day. So you see, this is so much more perfected. Of course, a decade ago this was running smoothly, but then a decade of regressions, there were some small little hiccups here and there. All the many live streams, all the small like, yeah, so many details. I probably improve this further. So one thing I will improve next is making this more intelligent so that the installer at least is suggesting for multiple mount points the second time not root, but more intelligently, like on x86 boot EFI, on other architectures in general than like home or /serve or whatever, at least something more useful. And sometime soon I will not only change this to mount by UUID because it's 2020, but also I started already, but finish integrating full disk encryption here because why not? And DTART is making their unholy jokes, but yeah, file system. Anyway, but this is not Riser 4. I'm not supporting Riser 4. I tested earlier BetterFS, XFS today, but yeah, that's it for today. Let's see if this installs, full install, because why not? Let's see if this installation glitch is gone now. I guess it is gone. Then I can sync this to the server for you to play along at home. And somehow the cable doxes gods today were with us with only 70 drop frames, which are 0.1%. We are already past this, so yeah, just some random compression stuff. So yeah, small installer updates also to come. Then some really strange, bizarre thing on some cross build or some architectures like PowerPC. Some spaces are gone in this dialog stuff. There are new regressions because what would 2020 be without upstream regressions? Super bizarre, not yet really sure why that happened. So that is, I need to check this another day. And as usual, if you have patches and test this ISOs and have stuff, and always looking forward to your patches and comments. please configure grub for us. Let's see if it installs with riserfs. No errors back here. And then it's that for that today, unmount and reboot. Also, another small thing I will fix really soon, maybe even tomorrow or tonight, is right now on boot up we get some stray warnings from UDEV of some groups and users not found, like group disk and whatever stuff. You will probably see this here soon. And boy, have I cleaned up this booting already. This booting already looks so much cleaner than last year in our T2 stuff. But yeah, this is a tape group and whatever. Can we scroll? I can't really scroll much back. Anyway, yeah. Also, the system boot up stuff looks already so much more amazing. So yeah, it's booting. So this is root. Oops. This is here the real stuff. Root test. Let's file here bin bash. That is 32-bit LSB executable x86-64. We could, by the way, DH client. It's one last test before we publish this, because testing, more testing is most testing and can never test enough. Let's see if we can check out and build our. Also, yeah, I eventually need to get rid of this strange directory. This is also some strange glitch. Check out https code t2 trunk permanently, please. And let's see if we can actually build T2. Wouldn't make too much sense to publish the ISO. T2, I cancel this here. SVN up misc of SVN clean up. Just a little bit of short thurkening that here. Let's see if we can misc archive. Can we compile a hello world? And what is the output? That is, yeah, it's defaulting correctly, because if the compiler is not defaulting to the correct system default, then all the stuff gets mixed up, and it's a pain in the ass to build stuff if the system default is not matching the compiler default. So then as we up this, then probably it should probably work. It's good to publish. So if you ever wanted to play with the x32-bit 5 to 8%, sometimes faster, unless it's not, then ISO coming your way here at the usual DL download DL T2SDE.org /binary 2020 there in probably some hours later today. That's it for today. I hope you learned something and enjoyed this fast speaking, fast paced technology update here on the open source and Linux technology front. Now I have to go for lunch. What else do we have here? Except some Riser stuff. And yeah, again for the Superjet and T0 set standard, we use this already. Does it work for compression? I think. Does it work for compression, only decompression? It might be that this parallel stuff only works for, but anyway, we are using this T0 here in, as you see, for compressor. Ultra 20 T0 is here the default, but I think this is only for decompression. T whatever, what T is equal to T0 whatever. T for threads is compress using detect use number of physical cores threads kept. It's standard. Or is it for interesting? It says compression, but why somehow? Anyway, we're using this, but somehow. Anyway, you manage memory. What do we have here? This is still checking out. So Nova prospect, welcome, city 17, chosen or been chosen, enter one of the finest urban centers. What you are talking about, Half-Life reference, okay, cool. From whatever something, if he is becoming the norm on ARch risk as well, maybe won't need to turn it off for them either. You can use efi-verse command to determine whether your installer is booted with efi. Yeah, that's a good hint. Also, I'm not a huge fan of efi. It's super complex stuff, so I'm not really sure, honestly, but leave in the comments below. Similar to ACPI, we love certainly beautiful small stuff here, and efi super complex stuff. I really would appreciate if you would boot on in more keep it stupid, simple, minimal, beautifully firmware. efi is too complex for my taste, and yeah, but leave in the comments below what you think. So config is coming up. This probably should default correctly, hopefully, to we have an option for that, which is default to 32-bit x32 for user space application. And then let's emerge here something like ETH, although that probably might not work. Yeah, some new dependency, but in general it looks like it does work, except when, why is this erroring out? Let's try something else. Does that work? Also not. Do we have some general issue of some sort? But anyway, tool or ETH tool, whatever is up with that. Not enough memory. What? Ah, okay. So sets are not. Yeah, I probably should boot with some not. We are running with some very minimal of QEMU. Yeah, Ultra 20. Not enough for some 512 megabyte of memory. Anyway, that's really it for today now. Detailed agrees with U-boot for president, and yeah. What else do we have there? No prospect loves M1P5. ZFS approach. Which ZFS approach do you mean? Greetings to Georgia. Microkernel says I should go see my family. Certainly will do now. Although I was already the one who was feeding the babies the whole night, so at least wife could sleep and is happy. Not a fan of efi, but the firmware isn't there. And if only x86 based systems came with Petit boot, yeah, that would be fun stuff. And yeah, so cool stuff. Thanks everyone for tuning in. As usual, we have the most people joining when we are done with this topic, which certainly is a good thing, but you probably want to rewind and watch all the stuff at least the beginning anyway. So this ISO is pretty tested, works pretty well. I arsing this not to the server. Don't forget to share, like, and subscribe for all the open source software, hardware, and stuff business. Probably coming sometime soon, except I've basically a very long list of video stuff and ideas and stuff to work on. You probably have guessed it. But coming sometime soon is actually testing RISC-V, someone else's RISC-V pet project update, which previously on the FPGA Icebreaker and ULX3S FPGA fame, we were running a non-pipelined Pico RV32, and there is an update for that. So probably sometime soon we will do some more Verilog code, continuing our RX32 RISC-V system, including not only making all this audio and video stuff more amazing, but testing someone else's RV32 update, new Verilog softcore RISC-V CPU with support for pipelining. I have not testing it, that I got some sneak peek there, actually, not sure. Anyway, so yeah, coming up there. So hopefully for our homebrew RX32 system, some nice performance update with some pipelined, pipelined of fetch, decode, what was it? Anyway, something of the sort. Fetch, read, execute, write, something of that sort. Anyway, need to check it. But yeah, hopefully that is an important performance improvement for our RISC-V stuff here on the FPGA, and certainly a million of updates, millions, how long will they live? Anyway, You get the idea, thousands of videos coming there your way, and I hope to see you soon for all of those fun stuff, and I hope to see you soon for all these updates coming next.